data set and enabled to protect output based on provided training. Hence, the machine is trained with the input and corresponding output. Unsupervised machine learning. Unsupervised learning refers to a learning technique that's devoid of supervision. Here, the machine is trained using an unlabeled data set and is enabled to predict the output without any supervision. Next slide. Supervised machine learning is further classified into two broad categories, which is classification and regression. On the other hand, unsupervised machine learning is also classified into two types, which is clustering and association. Next slide. Classification. These refers to algorithms that address classification problems where the output variable is categorical, which is yes or no, true or false. Few real world applications are spam detection and email filtering. For example, if the classifier was trained to identify whether or not an image was of a lion, that it might give as yes or no. Next slide. Regression. Regression algorithms handle regression problems where input and output variables have a linear relationship. These are known to predict continuous output variables. Examples include weather prediction and market trend analysis. For example, how long it will take to drive from point A to point B. Next slide. Clustering. The clustering refers to grouping objects into clusters based on parameters such as similarities or differences between objects. For example, customer churning, which means grouping customers by the products they purchase. In this slide, the data of hand-drawn images are moved into clusters with same number. Even within clusters of the same number, the images are clustered by those which are similar in shape. For example, here similar structures of twos are grouped as one cluster and seven are grouped as another cluster. Now Siddharth will continue.
Hello everyone. My name is Siddharth, and we will be see in deep about what regression is. So regression is a statistical method that that used to analyze the relation between a dependent variable and one or more independent variables. It seeks to determine the strength and nature of this relationship, allowing us to understand how changes in the independent variables affect the dependent variables. So, by fitting a regression model to the data, we can quantify this relationship and make predictions or draw conclusion based on the observed data. So these are the few types of regression models. So we have two type of regression models. One is simple and multiple. In simple, we have a linear model and a non-linear model, and in multiple, linear and non-linear. So in simple, we will be taking only uh, one independent variable, whereas in multiple, we'll be taking multiple variables, multiple independent variables. Uh, yeah. So in linear regression, we will be establishing a equation which will be finding the best fit line by minimizing the uh, error, which will be a straight line. So this is the uh, graphical representation of a regression line, a positive linear regression. So the equation of this positive linear regression would be y equals to b naught x1 plus beta 1, and we have a negative linear relationship where the slope will be negative. Next one. So the logistic regression. The name might confuse you, like logistic regression, but it's not a regression technique. It's a classification technique. So the classification is a machine learning technique used to categorize data into predefined classes or categories based on the features. So classifications output is The output of logistic regression is transformed using the logistic function, which produces a shaped curve. Can you show the next slide? Yeah. So this will be the output of a logistic regression. The threshold value is used to classify the data points, typically set at zero point 0.5, above which the data points is assigned to one class and the below which is assigned to the other. Next, classification. Classification, as I said, classification is a machine learning technique used to categorize the data into predefined classes or categories based on their features. Features is nothing but the columns. Uh, so we will be seeing. Can you go to the next slide? Yeah, decision tree. Then this. So we will be breaking our data set into decisions. We will be drawing a decision tree like uh, where we get the output or yes or no. Can you go to the next slide? Yeah, there are so decision tree algorithm can be solved in two methods: CART as well as ID3 algorithm. Uh, so decision tree algorithm is basically used for classification and regression for both classification and regression problems. Can you go to the next slide? Yeah. So these are the basic components or terms which will be used in a decision tree. Like root node refers to the starting node of the decision tree, and the node is the which will be the middle node or the node or the condition which will be giving the output. The leaf node will be the final decision or the last node of the decision tree. Yeah. So this is the decision tree which will be getting in when we apply decision tree. So first we will be having the root and then the node and then the leaf. Uh, then clustering algorithm. Clustering is nothing but we will be grouping the similar objects into one group. This is a clustering. So we will be seeing how the clustering algorithm will be working. Can you go to the next slide? Yeah. So uh, this is the one type of clustering algorithm, k-means clustering algorithm, in which we will be taking k as a parameter, where k decides how many clusters should be made. So here are a few steps for how the algorithm works. First, we will be randomly assigning each object to one of the k clusters. Then we will be calculating the seed points as the centroid or nothing but a mean of the current clusters. Then assign each object to the cluster with the nearest seed or nearest mean point. Then iterate 2 and 3 until the assignment of objects to cluster no longer changes or a, st- uh, until a stopping criteria is met. Next, we will be seeing it in a graphical manner. So first we have an initial data set which is random, like there is no clusters made. Then your k is equals to 2 means we are choosing cluster as 2. We will be making two clusters, and uh, so we made two clusters, and we will be finding the mean. Here you can see in third box that a blue color is made, which is nothing but mean. Then we will reassign it or make it to a cluster. As you can see, then third box the plus is made to the plus symbol is made to a dot one. You can see that is represented in yellow highlighted. So we will be updating till there is no further updatement is done. So this is how we will be making or using a k-means clustering. So next slide. So this is how when we find a mean, we will be checking the distance from the mean and the point and the other mean, and the point distance, which is the closest we will be assigning to that cluster. So yeah, this is the algorithm where we'll be picking C centroids at random, and we will be assigning the points to a cluster nearest to the centroid, and then we will do it again until we there is no further change made. Yeah, next. So the Streamlight coding and all will be explained by Mohammed. Over to you, Mohammed.
Just give me 1 minute. So, hello everyone. My name is Mehmood. Uh, I'm a fourth year from CSC, and I will be explaining to you about Streamlit. So, Streamlit is an open source Python library that allows you to easily build web applications for machine learning and data science. Simply put, it is a web library which allows us to add machine learning models to the web. It is very famous because of its simplicity and speed. Streamlit is mainly popular because of its easy syntax, interactive widgets, and deployment options. So now I'll be showing you a sample code for deploying linear regression using Streamlit. So first we import Streamlit as st, and from sklearn.dataset we import the iris dataset, which is a dataset that contains about 4 species of flowers. Then we import the linear model, which is a linear regression model. Then from sklearn.model selection we import train test split to split the data into training and testing data. Then we import numpy as np for n-dimensional arrays. After that, we import matplotlib.pyplot as plt for plotting the graph, and cbon also for plotting the graph. The next step is to load the iris dataset. Here we are declaring a variable iris, which will take data from the iris dataset. Here x is a variable in which it is selecting two parameters or two features, actually two features, which is the sepal length and the petal length, and y is the target variable, which is what is the species. Is it setosa, versicolor, or virginica? Then the next step is to split the training data. To split the data into training and testing data, here we are splitting the data into x train, y train, x test, and y test. The test size is 0.2, so 80% of the data is training data, 20% of the data is testing data, and the random state is 42. So that we don't go in a sequence but take random entries from the dataset. Here we are declaring a variable as LR, which is called the linear regression function, and here we are fitting the x train and y train data. We are fitting the training data here. Then we are declaring a variable called ypred, which will predict based on the data present in x test. Then we simply define a function display LR model. Here we are importing Streamlit as st.subheader. The linear regression model will be the subheading. st.write coefficients, st.write intercept, and st.write R2 score. R2 score is a accuracy measuring. R2 score measures the accuracy of the model. It tells about how accurate the model is. Then we are calling another function as display actual versus predicted. This function will help us show the actual values versus the predicted values by the model. This is a scatter plot. That's why plt.scatter, y test and y pred. So y test is the actual data, y pred is the data which the model has predicted. Now we are creating a Streamlit app. st.title linear regression iris dataset is the name of the app. st.write, this app displays it tells us about how it tells us about what the app is going to display. Here is the function calling the app. Now let's run this. One second.
Mahmood, it might be some dependency errors. We can just send over the code to the participants after the event so that they can try it on their own if it's not working.
Yeah, it's not working right now.
Fine, we'll send it over. We'll send the code over to the participants and they can go for it.
Okay.
So it is having a small quiz. I'll be sharing the link in the chat box. The link of the quiz is in the chat box. Everyone can just start. We're waiting for all the participants to join in. Remember that the results of this quiz will decide on who the swags will be going to. We'll be starting the quiz in a minute. Okay, we are starting the quiz. So, hope you all enjoyed the quiz. So, that's it from our side, and let's conclude the session. Thanks everyone for joining. Those who have participated well in the quiz will be contacted by the team and will be given the swags. You all can leave. Thank you.